180 degrees. So clearly we can, by unitary method, we can say for 30 degrees it's just 5 by 6 radians. So similarly, we can interchange degree and radians whenever we want to, right? By remembering this simple equation, which is 5 radians is 180 degrees. Simple. And yeah, so this is the equation. They just basically use the unitary method here, that if 5 radians is 180 degrees, then for other radians, what is the degree measure? And for degree measure, what is the other radian? We can similarly convert all degree into radians and radians into degrees. It's quite simple. Let's move forward. Let's take this example, let's say. So find the radius of a circle in which a central angle of 60 degrees intercepts an arc of length 37.4 centimeters. Okay. So there's a circle, normal. There is basically what we need to find, the radius of the circle. Okay. So we know that they the arc would subtend 60 degrees at the center. That's what we mean by the central angle, right? So it's subtend 60 degrees, and so we know relation that r theta is equal to L. You need to remember this relation, which is very important. So r theta is equal to L, right? Because definitely, of course, you know the by the selector formula, right? So when we put L is what? L is the length of the arc. So that is given to us. We have been given with the theta also, which is 60 degrees. So by just substituting in this formula L by theta, we can clearly get R. So it was that simple. Let's see another example. If the arc has the same length in two circles, subtend angles this and this at the center, find the ratio. Yeah. We can still again use the same relation because the arc length is the same. We can equate r theta is 1, r1 theta 1 is equal to r2 theta 2, right? By putting the values in this, we can get the ratio of the radius. That's simple. Let's move forward. Let's go into the more core of this chapter. Let's move further with the trigonometric function. Okay. Okay. So you all know sin x and cos x is right. And I need not go into that much detail too. You all know what is sin x and cos x. So sin x equal to 0. We need to find those values of x where this function 0. And so that comes out to be n pi in case of sine, and it's 2n plus 1 pi by in case of cos x. Okay. And we all know these types of functions. Cos x is equal to 1 by sin x. Now see, why is this written here? Why is x not equal to n pi? Because if you put x equal to n pi, we saw here that sin x 0 at x equal to n pi. So if you put x equal to n pi here in cos x, you put that value in sin x also, which is in denominator. And if the denominator is 0, we know the thing is undefined, right? So all this, the cosec x is equal to 1 by sin x is valid only for values which are not n pi. That's easy. Similarly, we can define sec x is equal to cos x. Tan x is sin by cos, and cot is cos by sin. Right. Achha, another thing is, we know that sin square x is plus cos square x is equal to 1. This is the identity which you need to remember, and which you must have remembered by now, because it is used extensively in every uh, subject. So sin square plus cos square is 1. And we know that when we divide this whole equation by cos square x, we get tan square x plus 1 is equal to square x, right? So we will get this equation. If we divide this equation by sin square x, we will get this equation, which is 1 plus cos square x is equal to cos x square. You also need to remember these both. So these three identities, sin square plus cos square is 1 plus tan square is cos x square, and 1 plus cos square is cos x square. You need to remember this, okay? You cannot forget these values. And this table is really very important because these values, 5 by 6, 5 by 4, these corresponds to 30 degree, 45 degree respectively. So all these degrees, all these radians, you need to remember by heart because it is really very, very used extensively. Sine 5 by 6 should be half. That should be at the tip of your tongue. Tan of 5 by 2 is not defined. So these are very easy to remember because they are used extensively, right? Really very used extensively. So yeah, again we know, so the thing is, you know that cosec x is equal to 1 by sin x, right? So you need not remember tables for cosec x because you anyways can find the sine of that value and then just reciprocate it to get the cosine of that value, right? Another thing which is very important is the sign of the trigonometric functions. So let a comma b be a point on this unit circle, let's say. Define this BOA as angle x, right? This AOQ, which you see, this is anti-clockwise angle minus x. So this here is negative and this is positive. This clockwise, sorry, clockwise is negative and anti-clockwise is positive. This is the convention. So we know that cos of minus x is equal to cos x. Sine of minus x is equal to minus sin x. This is also very important, right? Likewise, we have the signs of all other functions in all the four quadrants of the circle. So the first quadrant, this is the second, this is the third, this is the fourth. So in first quadrant, all are positive, right? In second quadrant, sign of cos changes, and since tan is x is equal to sin x by cos x, sin x is positive, cos x is negative, so tan x is negative, right? So this is also important, which you will be able to derive from support two. Now let's come to more important part, which is what domain. So domain of all these functions are very important. Let's now start with the domain and range of these trigonometric functions. We know that sin x and cos x, only sin x and cos x, they are defined for every value of x belonging to real numbers, right? So it is defined on whole real line. So domain of this sin x and cos x functions is the whole real line, but the thing is their range is constrained. Their range is only from -1 to -1, -1 to 1. Okay, they cannot exceed 1 and they cannot go below -1. You need to remember this. From this, we can conclude that domain is all real numbers, but the range is only -1 to 1, right? Now let's move further. To find the domain of cosec x, we know that it is not defined for n bar, right? Because then sin x becomes 0. So that's it. Domain of cosec x is nothing but all real numbers excluding n bar, right? And range beyond it's either less than equal to -1 or greater equal to 1. Similarly, we can find the domain of sec x, which is all real numbers ex, uh, except to an odd multiple of 5 by 2. And range is again like cosec x, which is minus infinity to -1, or it is either greater than 1, equal to 1, right? Similarly, we can find the domain of tan x, where x is again the set of all real numbers excluding odd 5 by 2. Why? Because tan x is equal to sin x upon cos x, and cos x equal to 0 we cannot afford because then this tan x would become defined. Hence, we exclude 2n plus 1 5 by 2. Okay, that means all multiple of 5 by 2 because then cos x is 0. And range of this tan x function is all real numbers. This is all real numbers. We further observe that the first quadrant, if x increases from 0 to pi by 2, sin x increases from 0 to 1. Right? We all know that. Yeah. In pi by 2 to pi, sin, this sin x decreases from 1 to 0. This 1 was attained at x equal to pi by 2. So from x equal to 0 to pi by 2, it increases. So what we can conclude is from x equal to 0 to pi by 2. That is in the first quadrant, sin x is an increasing function. In second quadrant, sin x is a decreasing function. In the third quadrant, it is again a decreasing function where it decreases from 0 to -1. And in the fourth quadrant, it increases from -1 to 0. Right? So we have this table where all the behaviors of all the trigonometric functions quadrants is given. So let's say we shall see now cos. So in the first quadrant, it decreases. In the second quadrant, it again decreases. So what do you mean by again and again decreasing? It starts from 1 in the first quadrant at value x equal to 0. And until it goes to pi by 2, it goes to 0. Okay. I mean, as x approaches pi by 2, this cos function approaches 0. Once it touches 0, it again starts decreasing from the value to -1. This -1 is attained at x equal to pi. Similarly, this value -1 to 0, it decreases from -1 to 0 and then increases from 0 to 1 in the fourth quadrant. You can similarly look up all these behaviors from this table. This thing is damn important for JEE. Really very important to know this. Okay, so I would give you a second to see that can we portray this uh, behavior of all the trigonometric functions on graph. So as you can see, now let's analyze the table and the graph together. So as you can see, as x is increasing from 0 to pi, this is y versus x, y sin x. Okay, so x is as x is increasing from 0 and going towards pi, you can clearly see it's increasing, and it's in the table also that it's increasing from 0 to 1. Right, it's increasing from 0 to 1, and in the second quadrant, which is pi by 2 to pi, it's decreasing from 1 to 0, then going from 0 to -1, then going from -1 to 0. Okay, right. So yeah, this can be analyzed using the graph. All these trigonometric functions can be represented on a graph. And I would say instead of remembering this table, you should be able to draw these graphs in a JC. Okay, these graphs are really very important. Why? The reason I'm stressing is because J means math questions. All I mean, many questions can be solved using these graphs. I mean, these graphs are like an important part of the solution of all the questions. You should remember, or you should not remember, you should practice these graphs again and again in all the questions. Okay. Like instead of solving it algebraically, you can solve it graphically also. That's what I mean. So again, let's take an easy example. Let's say if cos x is equal to -3 by 5, and it's given that x lies in the third quadrant. Why do they give this? Because see, cos x can be negative in two quadrants, right? Which are those two quadrants? It is second quadrant and it is third quadrant. So x is sorry cos x is negative in second and third quadrant both. So they gave information that x is in third quadrant. So we now surely know that it is in third quadrant, and we need to find the values of other five trigonometric functions, which is sine, cos, sine, tan, cot, cosec, and sec. So once we know that cos x is minus 3 by 5, we know sec x is just reciprocal of this, so it becomes minus 5 by 3. We know that sine square plus cos square is 1. Putting cos square value in this, we get sine x is equal to plus minus 4 by 5. Now this information comes handy. Since x lies in the third quadrant, we know that sine x is negative. We have to reject the positive value and we get sine x equal to minus 4 by 5. And by reciprocating it, we get cos x too. Next, we know it's sine x by cos x and cot x we know it's cos x by sin. So it's pretty easy. You just need to make sure you read this information. Otherwise, you will mark sine is equal to plus minus 4 by 5 both answers, right? Similarly, these other questions are there. I will not waste time solving same question again. Let's see this question. Find the value of sine 31 by 3. Okay. So let's see this now. Okay. So thing is that we do not see. The thing is, if we see this graph sine x, either we go to the way all over to the weight of 31 pi by 3. That's not possible, right? We need to draw the second again. Or we can use some intelligence in this. The thing is, we know that sin x repeats itself after every 2 pi interval. So you see here, it's going from 0 to pi, then pi to 0, pi to 2 pi. And the shape of the graph, the value, see, to check if the graph repeats or not, we need to check that every value should repeat at x. Okay. So if you see the graph shape looks same. The values also it attains are same after every interval of 2 pi, right? 2 pi, 2 pi. Then again, from minus 2 pi to 0, minus 4 pi to 2, minus 2 pi to 2. So it's important to understand that it's repeating after every 2 pi intervals. You can say it is also repeating after every 10 pi intervals, right? Because 10 pi can be divided into 2 pi, 2 pi, 2 pi, 2 pi, 2 pi. And all those things are same. So we can write this 31 pi by 3 as 10 pi plus pi by 3. And we can reject 10 pi by 3. Why? Because it's then the value of sine at pi by 3 and the value of sine at 10 pi plus pi by 3 is the same because it's repeating itself. So we can just say that this value is equal to sine pi by 3. And we all know this is root 3 by 2. So this was a clever way of doing this question, right? So yeah, again, this exercise there, we can solve this to like we can solve this to like understand the same stuff which I've been teaching right now. You can solve it yourself to do, right? I've given you two examples here, and 31 pi by 3 and just explained you all, right? You can now do this exercise simply. Let's move further. Yeah, see before that sine of minus x is minus sin x and cos of minus x is cos x. By this, we can now prove cos x plus y is equal to cos x cos y minus sin x and y. I don't think I should waste time in explaining the proof. It's quite simple. You can understand it yourself too. But you need to remember this by heart. That's for sure. Cos x plus y is equal to cos x cos y minus sin x and y. Like this is used extensively, right? So cos x plus y is equal to cos x into cos y minus sin x into sin y. Remember that. Similarly, we can replace in this equation y by minus y and we get this equation. Cos x minus y is equal to cos x cos y plus sin x y. This equation again cos pi by 2 minus x is equal to sin x. Cos sin pi by 2 minus x is equal to cos x. Sin x plus y is equal to sin x cos y plus cos x sin y. Sin x minus y sin x cos y minus cos x sin y. And again, these four even this. So these are so again all these 12, 13, 14, 15. How many are there? 16, 17, 18, 21. So okay, so rest of the chapter contains only these identities only. So you need to know all these identities. They are super important. They are used throughout the maths, throughout chemistry, throughout physics, in all the 2 year syllabus of JEE-Mains. Okay, these are very basic ones, and I guess you must be knowing this by now. We have JEE-Mains next year. So let's start again. We know sine of minus x is minus sin x. We know cos of minus x is cos x. We know cos x plus y is cos x cos minus sin x sin y. We know cos x minus y is cos x cos y plus sin x sin y. Right? So these identities again are very important. And these are very simple again. Right? I can tell you a trick to remember sin x plus y, let's say. For example, if you want to remember this, just multiply sine of x with the cos of another. I mean, you need to add two things here. Sine of one thing into cos of another thing, then cos of one thing into sine of another thing. Right? Right. But in case of cos, what you need to do is you need to multiply cos of both and then and then add sine of both. Right? You don't need to interchange. So likewise, you can remember all this stuff. This is very important and very easy to. So tan x plus y is tan x plus tan y upon 1 minus tan x tan y. So one thing is very important in all this stuff. You need to take care of the domain. Yes, sorry. Let's move forward. Yeah, one thing I was mentioning here is that we need to take care of the domain. Every trigonometric function that we are using, we are using tan x. So we need to take care of this domain, which is x should not be an odd multiple of pi by 2. Y should not be an odd multiple of pi by 2. X plus y should not be an odd multiple of pi by 2. We need to take care of this. Okay. This cos plus identity is very important. It's cos square minus sin square. It's equal to 2 cos square x minus 1. And it is also equal to 1 2 sin square x, which is also equal to 1 minus tan square upon 1 plus tan square. You can verify this identity by putting tan square is equal to sin square x upon cos square x. Okay, it's the same thing. You can similarly use this identity. Sin 2x is equal to 2 sin x cos x is equal to 2 tan x upon 1 plus tan square x. See, these properties are really very important, and I hope you remember this. Okay. Similarly, we can define sin 3x, cos 3x, tan 3x, and this too. Now, see, this is what? This is factorization formula. Okay, so cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. Similarly, we can define these three too, right? So these are very important again, right? So yeah, all we can do is we can factorize cos x plus cos y. We can factorize cos x minus cos y. We can factorize sin x plus sin y. We can factorize sin x minus sin y. All these four formulas are very, very important. So let's discuss one proof. So let's say we know that cos x plus y is cos x cos y minus sin x sin y, and cos x minus y is this, right? When we add and subtract both of these, we get this equation. So cos x plus cos x minus y, it is equal to 2 cos x cos y, and cos x plus y minus cos x minus y is equal to minus 2 sin x sin y. Okay, so these both are very, very important. Again, sin x plus y, we know that it is sin x cos y plus cos x sin y, and sin x minus y is sin x cos y minus cos x sin y. Okay, so what we did is we wrote these two equations, add and subtract them. We wrote these two equations, again added and subtracted them. Now we are replacing x plus y by theta and x minus y by phi. We get this x is equal to this and y equal to this in terms of phi and theta. Okay, okay. So okay, so again, when we put this x and y, so what we can do is we can put this x and y here in this equation. When we do this x plus y is theta, so cos theta plus cos phi is equal to 2 cos of theta plus pi by 2, theta minus pi by 2 cos. Right? So it's just playing with numbers. It's just playing with equations. That's it. Hence, we have proved this first identity with the cos x plus cos y one. Similarly, prove all these three equalities. Sorry. Okay. And these four are known as defactorization formulas. What are these? These are basically just the opposite of these. This is basically writing it in opposite way, right? 2 cos x cos y is equal to cos x plus y plus cos x minus y. Minus 2 sin x sin y, cos x plus y minus cos x minus y. All these four identities are again kind of same. Let's see this example now. Okay, so 3 sin pi by 6, sec pi by 3, minus 4 sin pi by 6, or pi by 4. This is a very straightforward example. We use sin pi by 6 is half, and so we can just, you remember that table, right? Where all the trigonometric functions for basic and this were given. So we can just put in the values here and get the RSS, right? That's simple. Okay, so let's move forward. Now let's these things also come very handy. Sine 15 degree, cos 15 degree, tan 15 degree, cot 15 degree. All those values can be derived easily, and if you can remember those, it's it's good if you remember those, okay? Because sometimes they come handy in JEE-Mains. Not always, but still sometimes. Let's say we need to find sine 15 degrees, okay? What we can do now is we can write sine 15 degree as sine of 45 minus 30. It's the same thing, right? and we can apply sin x minus y formula. We know that sin x minus y, sin x cos y, and minus sin y cos x, right? We can just now what? Why did we write only 45 minus 30? We could have written 60 minus 45 too. We can write 60 minus 45 by the way, but we could have written 18 minus 3 also, right? Thing is, when we defactorize this into this, right? When we do this, thing is, we know sine 45, we know sine 30. These are basic trigonometric formulas, right? Trigonometric angles. So we know the values of sine of both these angles. We know the cos of both these values. So that's why we wrote 50 as 45 minus 30 and not 18 minus 3. Because we do not know sine 18 yet. We don't know sine 3 yet, right? Sine 45 is easy to calculate, hence we wrote that. And by using the defactorization formula, we can come to the value of root 3 minus 1 by 2 root 2. If you could remember this value, I would suggest you to remember, otherwise it's fine. Now let's say we need to prove sin x plus y upon sin x minus y is equal to tan x plus y, tan y upon tan x minus tan y, right? So sin x plus y can be written as sin x cos y plus cos x sin y, and similarly sin x minus y can also be written. When we divide the numerator and denominator by cos x cos y, we get the value as tan x plus tan y upon tan x minus tan y. How? Because when you divide this by cos x, let's say we are dividing numerator by cos x cos y. Okay. So sin x cos y upon cos x cos y would be tan y. Cos x sin y upon cos x cos y would be tan y, right? Tan x. So this would be tan x, would be tan y. And hence we get tan x plus tan y numerator. Similarly, we can get tan x minus tan y denominator also. Okay. So another thing, this identity, this is very, very important. This is used extensively, and I would suggest you to remember this. Okay. This you should remember by heart. Okay. So let's say tan 3x, tan 2x, tan x. This is nothing but tan 3x minus tan 2x minus tan x. Okay. How can we prove that? We know 3x is equal to 2x plus x. When we take tan on both the sides, we get tan 3x is equal to tan of 2x plus x. Okay. And hence tan 3x is equal to tan 2x plus tan x upon 1 minus tan 2x tan x. So tan 3x minus, again, so basically what we do now is what we did here is tan 2x plus x can be written as tan 2x. Again, so what we did is tan x plus y formula we used. Where was it written? Let's see. Tan x plus y. Here it is. This formula we used, so we put x is 2x and y is x. So when we put it that way, we can get tan 2x plus tan x 1 upon 1 minus tan 2x tan x. So yeah, so tan 2x plus x can be written as tan 2x plus tan x upon 1 minus tan 2x tan x. When we cross multiply, we get this equation, and which can be written in this form. So yeah, it was pretty easy, and you should remember that this. Okay, sometimes we can give this equation as what is the value of tan 135 minus tan 96 minus tan 64 minus tan 32, right? So it's just multiplication of these three values. That's it. This is again a simple equation question where we just have to use factorization formula cos a plus cos b, that formula, okay? And you can get the value easily. Not quite difficult. And you must be able to solve it by now. After working hard for 2 years. Anyways, let's see this question. Prove that sine 5x minus 2 sine 3x plus sine x upon cos 5x minus cos x is equal to tan x. We need to prove this. Okay. So thing is, we just now rearrange these three values, right? So sine 5x plus sine x. So we just wrote it again in this way. And what we did is, since we cannot factorize sine 5x and 2 sine 3x together, but we can still factorize sine 5x and sine x, right? So we write sine 5x plus sine x, which can be written as 2 sine 3x cos 2x, right? Easily, you know that. Sine x plus sine y is equal to 2 sine x plus y by 2 cos of x minus y by 2, right? It's simple. So that, and even we can factorize cos 5x minus cos. We get minus 2 sine 3x sine 2x. When you look closely at this, you know that sine 2 sine 3x is common in numerator. We take and 2 we can cancel out. So from numerator and denominator, sine 3x into cos 2x minus 1 upon sine 3x sine 2x. Sine 3x gets cancelled and you're left with this. Now you're getting 1 minus cos 2x upon sine 2x. But you need the answer in form of x, tan x. You do not need 2x, right? What we can do is we can use properties where 2x can be converted to x, right? We know that sine 2x is 2 sine x cos x. And we know that cos 2x is equal to 1 minus 2 sine 2x. We just put it there. We get the values in terms of x. And hence, what we got is 10x, clearly. So we get the answer as 10x, okay? You need to know, you need to get this manipulations in your head, right? Like, you don't even need to remember the exact steps, but you need to practice a lot of questions to get the the clicking power of the manipulation in your mind in the exam, right? Okay. So now I guess we have reached the end of the theory part of the chapter. Please, let's start with the miscellaneous examples. So example 18. Okay. If you're given the value of sin x and cos y, and you know you're also given that x and y both lie in second quadrant, they're asking you to find the value of sin x plus y. This is kind of a straightforward question. If you could solve it in 1 minute, it would have been good, right? Okay, so let's start. Like sin x plus y, we know all that sin x cos y plus cos x sin y. We also know that cos square x is plus sin square x is equal to 1. So we can first of all get the value of cos x, which is plus minus 4 by 5. Now, to eliminate one of them, we can use this information, which is x and y both lie in second quadrant. Since x lie in second quadrant, hence cos x has to be negative. In that case, cos x is minus 4 by 5. Similarly, we get the sine square value, which is equal to 1 minus cos square, and sine y is also plus minus 5 by 13. Since y lies in second quadrant, sine y is positive, and hence sine y is equal to 5 by 13. We can substitute these values in this formula and get the answer. It was pretty straightforward question, right? Okay, let's move forward. Prove that this is true. Okay. Now let's understand how. Let's see what we need to do. We can figure out, but how does that click to our mind? That's more important. See, you know that you can use factorization and defactorization. Here, factorization cannot be used because how we use factorization, right? We have multiplication of cos and stuff like that. But you know that if you have multiplication of, you can still use defactorization, isn't it? So that's what we will do now. We will defactorize all these three counts. That's what they have written. Achha, why did we multiply half? Because we know that we can defactorize only when multiplying with 2. 2 cos A cos B is equal to cos A plus B by 2 plus cos A minus B by 2, right? So again, we defactorize this, we get this, we defactorize this, we get this. And after seeing it, we see that cos 3x by 2 gets cancelled. We get these values. And we again factor because see, we have not reached this value, right? And we know what is in RHS. RHS contains against the again the factorized form, right? We had only the factorized forms of the terms. We do not have this what we say defactorized form. Since here we get defactorized, we convert into factorized. And again we apply cos A minus cos B is minus 2 A plus B by 2 sine A minus B by 2. Right? So yeah, again, then once we get this, we can prove that it is indeed the RHS which we needed to prove. Move forward. Let's find the value of tan pi by 8. Okay. What is tan pi by 8? It's, I guess, 22.5 degrees, if I'm not wrong. Pi by 4 is 45. 45 by 2 is 22.5 degrees. So we need to find 22.5 degrees. Now, how to, again, let's start thinking how to solve it. Okay. We want tan of 22.5. And we know tan 5 is nothing but tan of 45 by 2 because 22.5 is 45 by 2, right? So we need to do something with double here, tan 2x, right? So we know tan of pi by 8 is nothing but, sorry, tan of pi by 4 is nothing but tan of 2 into pi by 8. So we can use tan 2x formula to convert into tan x formula. We know, let's say x is pi by 8. So we can take 2x, tan pi by 4. And then we can use tan pi by 8. You will get a quadratic coefficient tan pi by 8. Once you solve that, you will get the value. But we need to check that can both be true or not. We know this value corresponds to one value which is required in the question. And this question could be a small part of a big question, right? Hence I'm suggesting that. Anyways, let's move forward. Let's now solve this question. Prove that cos square x plus cos square x plus pi by 3 plus cos square x minus pi by 3 is 3 by 2. Okay. So if you see this, we have LHS equal to 1 plus cos 2x by 2. So see what we are doing is we know cos 2x is equal to 2 cos square minus 1. Okay. 2 cos square x minus. We are rearranging the terms to get the value of cos square x in terms of cos 2x, which is this. Similarly, we can write the value of this and this as this. So we just converted half angle into double angle.
Recording in progress.
Was it not getting recorded, sir? Anyways, let's move forward. We basically just converted the values from single angle to double angle. Why did we do this? Because we need to get rid of this 2, the square value, and we can get rid of this by using the double angle formula. Okay, okay, so let's move forward. So again, it was quite simple to convert into double angle. Now, when we add all these, we get there are 3 ones, and we have these 3 values. Now you see, we again combine these three by factorization. Thing is, why? What should we combine in these 3 terms? These 2 terms or these 2 terms on this term. We will start by combining these 2 terms, and there is a reason why we do that. Okay, cos 2x plus 2 pi by 3 plus cos 2x minus 2 pi by 3. There's a reason why only uh, 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 we only factorize these 2 terms first. See, cos a plus cos b is what? 2 sin 2 cos a plus b by 2, cos a minus b by 2. So a plus b, when you add a and b, you will get one term at least cancelled. When you add 2 pi by, sorry, when you add these 4 terms, 2 pi by 3 will be cancelled. Subtract, you will get 2x cancelled. Right? So yeah, okay. So basically, when we factorize this, we get 2x cos 2 pi by 3. And we know what is 2 pi or cos. We can find this by cos pi minus pi by 3. It's pretty easy. And when you find it, you will see the magic. Cos 2x and cos 2x cancel. You just left with 3 by 2, right? So that's what happens in such questions. When you're getting a constant in the RHS and you're needing to, you need to prove it to some expression. The expression will have some terms which will get cancelled at the end. That's why you're getting the constant, right? Yeah. So when we had this question left out, if tan x is 3 by 4, x is between pi and 3 by 2. This means the x is in third quarter. We need to find the value of sin x by 2, cos x by 2, tan x by 2. Let's start finding them. So since we know x lies in the third quadrant, okay, so we know that x by 2 lies between pi by 2 and 3 pi by 4. Why did we find the domain of x by 2? Because we are concerned with sin x by 2, cos x by 2, tan x by 2, right? So we know since x by 2 lies in second or third quadrant, we can say sin x by 2 is positive because we know sin of x is positive in second and third quadrant. Similarly, we can say cos x by 2 is negative. We know x squared x is equal to 1 plus tan square. So hence we get sec square x. Cos square x we can get by reciprocating sec square x. And we can get the value of cos x is negative 4.5. Why? We rejected positive 1 because cos x by 2 is negative by domain value. We similarly get sine value also. 2 sine square x by 2 is equal to 1 minus cos x, which is equal to 1 plus 4 by 5 is equal to 9 by 5. We get sine square x by 2 is equal to 9 by 10. And we accept only the positive value of sine x by 2. Why? Because we saw the domain and sign of that value must be positive. We get sine x by 2 as plus minus 3 by root 10. We reject the negative value and get sine x by 2 equal to 3 by root 10. So we got sine x value, we got cos x, we got sec x. By double angle formula, we know that 2 cos square x is equal to 1 plus cos x, right? So x by 2. We wrote 2 cos x 2 cos square x by 2 is equal to 1 plus cos x. Okay, so cos x we can write it as minus 4 by 5. 1 minus 4 by 5 is 1 by 5. We can hence get cos x by 2 value. Again, we reject the what we say positive value because we know that cos x by 2 is negative in the second and third quadrant. And again, we know how to calculate tan x by 2 clearly. Why? Because tan x by 2 is sin x by 2 upon cos x by 2. And that is nothing but minus 3. So yeah, that was miscellaneous examples. Again, so see, what was this chapter exactly about? This chapter basically contained an introduction of sine, cos, and tan, and all those cos x, sec, and cot, right? So these six values, first of all, you need to remember the values of these trigonometric functions at basic angles, which is 30 degrees, 60 degrees, 45 degrees, 90 degrees, 180 degrees, 0 degrees. Okay. First of all, we need to know this. Secondly, you need to know the identities which are there in this chapter. I guess there are 21, 22 identities. And don't get afraid. Those will only help you to remember these. It's not a board exam where you just need to rote learning problems, the identities, right? You need to know how to apply them. JEE-Main is not going to ask you this identity as it is. What is the value of this? They're going to frame a question in such a way where you have to use this as a step in the solution. Okay. So I would suggest do as many questions as you can, right? Where these properties are getting used. And I'm pretty sure that you will remember that after you will remember these identities after solving them. Okay. Yeah. These two things were most important in this chapter. So yeah, let's finish off for the day. See you next time. Thank you so much. Bye bye.